In this video, you will learn about ionic bonding and covalent bonding. Earlier this semester, what we were told was for binary ionic compound, how do we make that? We should have combining with a metal with a non-metal, and then we say that is a ionic compound. And if we have a non-metal combined with a non-metal, and we call that a molecular compound. But why? Why the metal over here combining with the non-metal, we form an ionic compound? For that reason, I am going to introduce two magical numbers. The first one is number 2. That is a magical number. The second one is number 8. So this is a super magical number. Number 2 is good for hydrogen, helium, lithium, beryllium, and probably also boron. Okay, boron is a combination. Boron, it can be also 2 and 8. And for the rest of the elements in the periodic table, number 8, this is the magical number. So what do I mean by magical number? That means the number of valence electron, if it's 8, if it's number 8, then the atom will be very happy. Okay, what do I mean by that? Let's look at the electron configuration. For example, if I have, let's say neon. Neon has 10 electrons. So let's write the electron configuration. It will be 1s2, 2s2, 2p6. Okay, so let's see how many valence electrons. Remember, the valence electron is the number of electrons that is in the highest principal energy level. In this case, look at the coefficient. The highest number is 2. So 2 is the valence layer. And how many electrons? So 2 plus 6, I have 8 valence electrons. That means neon is already very happy. Very happy means now it is inert. It doesn't want to react with anything. It's already satisfied with 8 valence electrons. Let's look at another one. Let's look at sodium. Sodium has 11 electrons, Na. It will be 1s2, 2s2, 2p6. Now we have 3s1 because we have an additional electron. Let's look at this one. How many valence electrons do we have? Let's see. Valence electron, we look for the highest principal energy level, and it has 1. Okay, so we know that it's not very happy because number 8 is the happy number, and now it has just 1. So how can it be happy? This electron, if I remove this electron away and left this over, so what will happen now? Now the valence electron will be 8. That means sodium would love to be removed by 1 electron and form sodium plus. That's why elements in the first group prefer to be 1 positive because they always have 1 valence electron. Okay, let's see more examples. For example, let's see argon. Argon, it has 18 electrons, so it will be 1s2, 2s2, 2p6, 3s2, 3p6. Now we have 18 electrons. Let's look at how many valence electrons. It's 8, so it's happy. That's why it's not very reactive, and that's why it's called a noble gas or inert gas. Okay, so let's look at the periodic table. So here are the configurations for each element. Okay, so let's focus on group number 17 now. Okay, so what do we have? How many valence electrons? 2 plus 5. So there are 7 valence electrons. In order to make the magical number of 8 valence electrons, what is the best way? Now we have 7. So if we can grab another electron, then it would become 8 valence electrons. And how do we do that? So let's say fluorine, for example, it has 9 electrons, and therefore the configuration will be 1s2, 2s2, 2p5. And that's how we know that there are 2 plus 5 equal to 7 valence electrons. And how can I get 8 valence electron? I need to grab another electron here. That's why fluorine would prefer to be single minus, 1 minus. When F minus, the electron configuration will be 1s2, 2s2, 2p6. Now it is very happy because it has 8 valence electrons. An ionic compound is formed when 2 ions combine together. We have seen sodium is preferred to become positive 1, become a cation. And fluorine is preferred to become an anion, a negative ion. So when sodium and fluorine, when they combine together, before they combine together, sodium would prefer giving off 1 electron to the fluorine, and fluorine grabs it. That's how it forms positive and negative. Once sodium donates the electron, become positive, it will be attracted to the negative anion. That's how they can combine together, and they combine together by electric force, by Coulombic force. Positive will be attracted to negative. That's how it forms together like this. And this is called ionic compound. And this type of bond is called ionic bond. So ionic bond means electrons are donated from one atom to the other atom. First forming ions, and then the ions get attracted to each other and combine together. We just have talked about ionic compound, ionic bond. What happened with nonmetal combined with nonmetal? Okay, so let's see. They don't want to donate electron. Instead, they're going to share the electron. Whenever they can share the electron, we call that covalent bond. What do I mean by that? Let's have an example. Fluorine. Fluorine has 7 valence electrons. So how can fluorine combine with fluorine? Because we know that fluorine is a diatomic molecule. Okay, so it cannot be donated electrons because 7 valence, rather it will love to gain an electron. But all the fluorines, they don't want to donate, so fluorine cannot gain from anywhere if the surrounding is only by other fluorine atoms. So let's see what this fluorine can do. 7 valence electrons. I'm going to draw the 7 electrons surrounding it. 1, 2, 3, 4, 5, 6, and 7. How about this fluorine over here? I'm also going to draw the 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Okay, what happens if these electrons can be shared together? That means when I try to count the valence electrons, I also count the one from the other fluorine. Now, with the fluorine on the left, I have 1, 2, 3, 4, 5, 6, 7, 8. 8 valence electrons. If I count for the fluorine that is on the right, which includes this electron over here, because these 2 electrons are sharing. So I have 1, 2, 3, 4, 5, 6, 7, 8. Also have 8 electrons. Now, since both atoms have 8 electrons, they are happy. And these electrons are sharing. So covalent bond is formed by sharing of electrons. Sharing of electrons. So this is called covalent bond. Before that, we have learned that a metal combining with a non-metal, and we will have an ionic compound, except for hydrogen over here. So what happened? Because hydrogen is from the first group, it should prefer to have a positive charge and forms a cation, H+, and therefore it donates an electron to somewhere over here, let's say chlorine. Chlorine would love to gain one, hydrogen would like to donate one, and can they form an ionic compound? Okay, so that is a very good question. That brings us to something is called electronegativity. Electronegativity describes how much an atom loves the electron. Okay, so in this periodic table, it shows the electronegativity of different elements. For example, when you look at over here, chlorine, it says 3.0. So electronegativity for chlorine is 3.0. For hydrogen is 2.1. The difference, it is 0.9. So that is the difference in electronegativity. And in general, just in general, here are the rules. If the difference is less than 0.4, the difference of electronegativity is less than 0.4, it is considered as a pure covalent bond. And if the electronegativity difference is greater than 1.8, it is considered as an ionic bond. If anything between these two numbers, between 0.4 and 1.8, it is considered as a polar covalent bond. Okay, so let's look back here. So HCl is 0.9, so it is between 0.4 and 1.8, and therefore it is considered as a polar covalent. Okay, how about silicon and phosphorus? Silicon, that is 1.8, and phosphorus is 2.1. So the difference is 0.3. So 0.3 is less than 0.4, and therefore this bond over here is a pure covalent bond.